Okay, so hello and welcome to this video lecture. So today we're going to continue with the main branches of geology. And as for our recap, we have tackled on the specialized sciences which advances geology in allied fields. So actually we have gone through with the first 5 of this, namely geophysics, geochemistry, geohydrology, glaciology, and seismology. In fact, we have viewed some of informative video lectures regarding glaciology and seismology. So today we're going to discuss the the last 5 of these 10 allied fields. So we have oceanography, rock mechanics, remote sensing, mining geology, and of course engineering geology. And after which we are going to tackle what is the significance of the subject in our civil engineering profession, as well as its role in the civil engineering field. So we have actually gone through with geophysics, geochemistry, geohydrology, glaciology, and seismology. So moving on to our next allied branch, we have oceanography. This is actually a scientific discipline concerned with all aspects of the world's oceans and seas, including their physical and chemical properties, their origin and geologic framework, and the life forms that inhabit the marine environment. So there are 5 major branches. We have biological oceanography, the chemical oceanography, and then the geological oceanography, the physical oceanography, and Palios Sonography. So first we have biological oceanography. So it is actually a study that investigates the ecology and biology of marine organisms in the context of the physical, chemical, geological characteristics of their ocean environment. So if you're fun to have a scuba diving, of course, you might want to enroll in this course or biological oceanography. So it deals with, of course, the marine environment in its oceanic food web, and the main purpose is to, of course, to sustain the marine environment and the food chain inside it. So another major branch of the oceanography, we have the chemical oceanography. It's actually the study of the chemistry of the ocean, whereas chemical oceanography is primarily occupied with the study and understanding of seawater properties and its changes. Ocean chemistry focuses primarily on geochemical cycles. So there is actually an interaction between atmospheric and the ocean, okay, or the bodies of water in our planet. So there will be an exchange of chemicals between the atmosphere and the oceans of our planet. So one of the primary topics in chemical oceanography is actually the ocean acidification. So our continued burning of fossil fuels is increasing. So when we have a fossil fuels burning, of course, that will emit carbon dioxide in the atmosphere. And then as a consequence, the oceans have been absorbing large amounts of carbon dioxide since this industrial revolution. So it is this increasing amount of carbon dioxide in the oceans that is causing the acidification. When carbon dioxide enters the ocean, of course, it will combine with seawater to produce carbonic acid. Okay? So it will increase the acidity of water. So hence it is lowering the pH level. So when the pH level of certain water or liquid is decreased, therefore the acidity increases. So what will be the effect? So although it is unlikely that the ocean will ever become actual acid, the term acidification refers to the process of the oceans becoming more acidic. So a consequence of the oceans becoming more acidic is the binding up of carbonate ions, which are used by marine creatures. So actually, marine creatures creates through carbonate ions. So anong ginagawa nila? They are actually taking advantage of the calcium to make shells and skeletons. So as the availability of carbon ions decreases, it becomes more difficult for these animals to build their calcium carbonate structures. So parang ang gumagawa ng bahay na yung hollow block mo ninanakaw. So it's something like that, no? So those marine animals are actually trying to build their calcium carbonate structures while we are increasing the atmospheric emissions transferring to our oceans, wherein it will actually be dissolved. Okay, and if that happens, calcium carbonate will dissolve also. So an important element for the skeletons of marine animals is calcium. But calcium carbonate becomes more soluble, natutunaw siya, with pressure. So carbonate shells and skeletons dissolve below the carbonate compensation depth. So calcium carbonate becomes more soluble at lower pH level. Okay, so ocean acidification is likely to affect marine organisms with calcareous shells such as yung mga oysters, yung mga clams, and then sea urchins and corals. And the carbonate compensation depth will rise closer to the sea surface. Okay, so that is the effect. So in turn, it will adversely impacting our other reef dwellers. So there will be a negative impact on the food chain under our ocean. Okay, so we have here a figure wherein the left portion is during the late 1800s, and then the right portion is the projected increased acidity of our ocean. So as we can see, before we have above 8 pH seawater level, okay, or seawater pH level, or beyond 8 before late 1800s, because on that year wala pang ganong emissions of carbon dioxide. Okay, so lower concentration of atmospheric carbon dioxide that are being exchanged in the oceans, and then it will turn to carbonic acid as well as free hydrogen ions, and then of course it will slightly affect the carbonate ions, and tong mga carbonate ions are those elements that will be needing for the formation of calcium for the marine organisms to form corals, mollusks, and other marine calcifiers. Okay? So in short, ito yung mga gumagawa ng mga shells or shell structures as well as shell skeletons. And then after how many years, of course, as we all know, we are being industrialized, and we tend to consume more burning, okay, and then as a result, we have more emissions of the carbon dioxide, and the tendency is, of course, it will have more exchange in the atmospheric, between atmospheric and the ocean. Okay, so in short, there will be more carbonic acid, more free hydrogen ions, and of course, itong mga carbonate ions na to, it will become now soluble enough to be mixed with HCO3, so it will become bicarbonate. Okay, so if that happens, kukunti na lang yung resources ng ating marine organisms to form their shell structures. So this is actually the perennial problem in the ocean acidification because of the carbon dioxide emissions on our atmosphere. Okay. So next, we have geological oceanography is the study of the geology of the ocean floor, including plate tectonics and Palios Sonography. So it is analogous to our structural geology as well as paleontology. So you know that paleontology is the study of fossil of animal remains on the rocks and earth materials. So this time, we are now referring to the marine animals underneath our ocean. And for the geological features, of course, this is synonymous to structural geology, wherein it is also concerned with some phenomena like faults, faulting, and geologic formations underneath the ocean. Okay. So basically, geological oceanographers and marine geologists explore the ocean floor and the processes that form its mountains, canyons, and valleys. So hindi lang sa continental plates, pero yung mga formations like mountains, canyons, and valleys is also true underneath or the oceanic plate in our planet. Okay, so in fact, mas malalim pa nga yung the deepest trench found in Marianas Trench comparing to the height of your highest mountain, which is the Mount Everest. Okay, so they also examine the volcanic processes, mantle circulation, hydrothermal circulation, yung mga processes na magma genesis, crustal formation. So the results of their work help us understand the process that created the ocean basins and the interactions between the ocean and the seafloor. Okay. So next we have physical oceanography. It studies the ocean's physical attributes, including temperature, salinity, structure, mixing, surface waves, internal waves, surface tides, internal tides, and currents. And the following are the central, okay, perhaps we can omit this one. So yun, these are the scope of the physical oceanography. So yung mga physical oceanographers na tinatawag is study the physical conditions and physical processes within the oceans. Mga waves, currents, gyres, and tides, the transport of sand on and off beaches. Of course, meron din yung coastal erosion between the land and the body of water, and then the interactions of the atmosphere and the ocean. They examine deep currents, the ocean-atmosphere relationship that influences weather and climate. Okay? The transmission of light and sound through water, and the ocean's interactions with its boundaries at the seafloor and the coast. So moving on, we also have Palios Sonography. So as we have said, it is a part of Geological Oceanography. So it is the study of the history of the oceans in the geologic past with regard to circulation, chemistry, biology, geology, and patterns of sedimentation and biological productivity. So yung mga paleoceanographic studies na tinatawag using environmental models and different proxies enable the scientific community to assess the role of the oceanic processes in the global climate by the reconstruction of the past climate at various intervals. So, yung paleoceanographic research is also intimately tied to paleoclimatology. Okay, paleoclimatology. Okay. So next we have rock mechanics. So it is actually a theoretical and applied science of the mechanical behavior of rock and rock masses compared to geology. It is the branch of mechanics concerned with the response of rock and rock masses to the force fields of their physical environment. Okay, so kung meron tayong subject na sa ating civil engineering, meron tayong soil mechanics, meron din tayong rock mechanics because we have different approaches in dealing with rock and to that of the soil. Okay, so practically we also need to know the concept of the rock mechanics. Okay, so of course in our civil engineering profession, rock mechanics is concerned with the application of the principle of course engineering mechanics to the design of structures na ginagawa sa rock. Okay, rock material. So the structure could include but not limited to a drill hole, a mining shaft, yung mga tunnel, yung mga dams or reservoir dam, a repository component or a building. Okay, so rock mechanics is used in many engineering disciplines, but primarily used in mining, civil, geotechnical, transportation, and petroleum engineering. Okay. So next allied branch is actually this one, remote sensing. So it generally refers to the use of satellite or aircraft-based sensor technologies to detect and classify objects on Earth. It includes the surface and the atmosphere and oceans based on propagated signals like electromagnetic radiation. Actually, the early version of this one is the aerial photography. So we have introduced that in presentation of the video called from informative video on the net, no? So it started through a hot air balloon and then aerial photography. So there are different angles. It was introduced when you take a picture above. Okay. So in here, the advanced technology now is using waves, lasers, as well as other relevant technologies. So actually, this remote sensing could be either active or passive remote sensing. So as we can see here in the figure, so the sun provides a very convenient source of energy for remote sensing. Okay. So ito, magsisilbi itong reflection. Okay. As it is for visible wavelengths or absorbed and then re-emitted. So itong thermal infrared wavelengths. Yun. So remote sensing systems which measure energy that is naturally available, like the sun energy. Okay? Ito yung tinatawag na passive sensors. So passive sensors can only be used to detect energy when the naturally occurring energy is available. Kung wala ng init or araw, so it cannot be possible. No? So for all reflected energy, this can only take place during the time when the sun is illuminating the earth. There is no reflected energy available from the sun at night. Okay? Energy that is naturally emitted, such as thermal infrared, can be detected day or night as long as the amount of energy is large enough to be recorded. So that's for the passive sensor system. So it will be needing the help of our sun to bounce back a signal to a sensor system. Okay. On the other hand, we have the active sensors. Provide their own energy source for illumination. So meron tayong active sensors on ground. So these sensors emits radiation which is directed towards the target to be investigated. The radiation reflected from the target is detected and measured by another sensor. So advantages for active sensors include the ability to obtain measurements anytime. Okay, kahit gabi, regardless of the time, day or season. Active sensors can be used for examining wavelengths that are not sufficiently provided by the sun, such as microwaves, or to better control the way a target is illuminated. However, active systems require the generation of a fairly large amount of energy to adequately illuminate targets. Okay? So some examples of active sensors are lasers, fluorosensor, and yung tinatawag na SAR or SAR. So in short, that is a synthetic aperture radar. Okay. So there are various types of remote sensing. We have radar, lasers, and other types such as stereographic pairs, radiometers, and photometers. So meron na tayo dyan sa Pag-asa. So several Doppler radar station. So this is a picture of one of Doppler radar station. So radar is actually the abbreviation for radio detection and ranging. So radar imaging can be used for important safety-related remote sensing tasks. Then one of the most important uses is for air traffic control and weather detection. This can tell analysts whether adverse weather is on its way, how storms are progressing. So kaya nga yung Doppler radar is actually the main equipment of your forecasters like DOST Pag-asa, because yun nga can detect the storm, okay, and the signal of the storm. So Doppler radar is a common type of radar that can be used both to collect meteorological data and by law enforcement to monitor traffic and driving speeds. So pwede rin sa traffic, ano? So yung mga overspeeding can detect. And other types of radars can create digital models of elevation. Okay? Or yung mga digital elevation models, or what we call DEM. Okay? So here another type of remote sensing is laser. So laser altimeters on satellites measure factors like wind speed and the direction of ocean currents. So altimeters are also useful for seafloor mapping, as they are capable of measuring bulges of water caused by gravity and seafloor topography. Varied ocean heights can be measured and analyzed to create accurate seafloor maps. So what is good in the laser is that yung laser waves can penetrate water. So therefore, it can detect the seafloor, okay, and the ocean heights with a precision, with a measured precision. So one particular form of laser remote sensing is what we call yung LiDAR. Ito yung actually most popular in these times. So LiDAR is the light detection and ranging. So this method measures distances using the light reflection and is most famously utilized for weapons ranging. So LiDAR can also measure chemicals in the atmosphere and the height of the objects on the ground. So we can see here in the photo that LiDAR technologies can be mounted on the aircraft and pwede rin sa drone technologies. Okay. So other types of remote sensing includes stereographic pairs created from multiple air photos. So it is often used to view features in 3D or make topographic maps. So radiometers and photometers that collect emitted radiations from infrared photos and air photo data obtained by the satellite. So the upper picture you can see the slide is the microwave radiometers, and below that is the sun photometer. So moving on to another allied branch is the mining technology. So it is an applied science which combines the principles of economic, geology, and mining engineering to the development of a defined mineral resource. So, nasan ba yung mga resources natin? So, of course, you need to have an exploration. Okay? We can see that in the slide. So finally, we have the engineering geology. It is also called the geological engineering, the scientific discipline concerned with the application of geological knowledge to engineering problems like reservoir design and location, determining of slope stability for construction purposes. Like ours here in Cordillera regions, we are being surrounded by mountains, and we are actually living in the mountains. So we really need to have the idea or the knowledge from the engineering geology. And for the earthquake, determination of the earthquake, the flood, subsidence, danger in the areas considered for roads, pipelines, or other engineering works. So now we move on to the importance of geology in civil engineering profession. Okay. So alam naman natin na when we have a project, so the very first thing to do is the survey. So what do you need to survey? It is just not only about the size of the site, but it requires all geological aspects and characteristics of the site condition. So the most important task for a civil engineer is the need to complete the site surveying. So of course, surveying requires civil engineers to determine the relative positions of points that are at, above, and below the surface of the earth. So we really need to have geological surveying. So we also need the tools and skills, like for example, in order to determine how blueprint points transfer to the real world. Of course, when we draw the plan, we are going to construct that to the real world, and then civil engineers must use direct and indirect means to measure things like distance, elevation, the orientation, the stratigraphy, the distance to the fault line. Okay, surveying and overall investigation of a site follow some step process, like gathering preliminary information from pre-existing data about the site, and then completing a detailed geological survey of the site, compiling survey data to form hypotheses about geology below surface level, then completing drilling and boring projects to confirm geological hypothesis. Why do we need to have a drill and a boreholes in our project? Because we need to investigate what really is the condition of our subsurface. Okay, so below your surface is the subsurface. So malay natin there are underlying parameters that we do not know, that is really crucial in our design. Okay, so overall it is a very detailed process, and of course no project requires a single civil engineer to complete all of this work alone. So hindi kaya to ng nag-iisang inhinyero. In fact, ang geological survey or investigation or exploration, it will really need a team to do that task, okay, because of its complexity. Okay, and of course, it is still important for engineers to understand some informations on geological parameters. Okay, so when providing civil engineering consulting, this information is crucial to a project's success. So as for the importance, number one, to recognize potential difficult ground conditions prior to detailed design and construction. So it helps to identify areas susceptible to failure due to geological hazards. So, of course, to establish design specs, and then to have the best selection of site for engineering purposes. So, if we have no choice, we do not need to select the site. Of course, knowing geological knowledge, having a geological knowledge would allow us to have the appropriate interventions kahit na mahirap pa man yung conditions of the site. Okay. And then, of course, to have the best selection of the engineering materials for construction. So, for the role of geology in the civil engineering profession, so geology plays a very important role in the field of civil engineering. So some applications of the knowledge of geology are given. So it provides knowledge about materials used for construction. So of course, geology includes the material component or the element of the material, as well as the atomic structure of the minerals or the resources that is used as construction materials. So another role is that its knowledge is helpful for river control and shipping works. So later on, we'll be discussing the formation of river, okay, and various phenomena on river, okay. And then next, its knowledge is helpful for constructing dams. Of course, when we know all of the geologic phenomena like valleys, formation of rivers, the catchment area, or what we call forested areas, or the watershed areas, if we know all of the aspects of that one, then those data or information are so helpful in dam construction, not only in its stability, but in its feasibility. Baka mamaya nag-construct ka ng dam sa isang river, pagkatapos biglang nag-dry yung river. So, tendency, your dam is like a white elephant na wala namang silbi. Okay? So, meaning, you should study the most feasible location of your dam, okay, in terms of water impounding and diverting water in agricultural fields, or you may want to use the energy out of the water, and of course we will consider the largest height or the largest head of the dam. Okay, so next, geotechnical engineers needs knowledge about this subject for digging work. Of course, when we construct a building, so hindi naman tayo basta-bastang maghuhukay. Of course, you need to assess the layers below your ground surface. where you are going to place your structure, no? Baka mamaya hukay ka ng hukay, biglang nag-cape in yung hinuhukay mo. So those are tragic events that we wanted to avoid. Okay, so not only on the parameters of the soil, but it is also on the digging work, okay, the layers underneath, whether your layer is saturated, basa ba yun, or baka naman dati siyang hollow, or it has at some point may mga liquefaction on the layers. So those are the things that should be known for us to have an appropriate solution. Okay, so next, its knowledge is required for foundation faults, and then for design of highways and roads, of course, especially in our province and our region. Our roads is along mountains, and nakikita naman natin sa mga daanan dyan, there are some road sections that are prone to landslide and caping in of your embankments, okay, which are also dangerous to the users of our road networks. So in construction of tunnels, it is also significant. So soil tests are done before any project. Okay, it is actually a prerequisite. So in any project, kailangan ng soil test yan, especially if we have mega structure or a high-rise buildings. Okay, so another role of geology is economical design is advanced. Why economical? Because we do not need to assume values. Baka mamaya ay nag-assume ka ng napakalambot na lupa, while in fact, if you're going to test or explore that foundation soil, matigas naman pala. So kung ganun, you can have engineering economy, or economizing the engineering design. Okay, so of course the nature of soil materials can be find out. So these are some enumerated roles of geology in our civil engineering profession. So with this, I think we can end to this session. So for the next session, we are going to discuss the scope of geological engineering, and then proceed to geological agents. So please prepare for another seat work or activity on the next meeting. So the scope of your activity will be the topics that was discussed on this video lecture. So class, thank you for listening and attending this video lecture. So see you on the next activity and lecture. Thank you.